If you're wondering what is this, I'm gonna tell you that. But first, how does it keep on working even without power? Hey Breakerspace, Dave here. So we have these Wi-Fi mesh pods across our house for better Wi-Fi coverage. One downside of them is that even if there's a power cut for a few seconds, they just reset. So if you're on a Zoom call, you just will drop. That's unacceptable. So I thought, why not make a small DC UPS for those Wi-Fi pods so that we can have uninterrupted Wi-Fi for our household. Now, this is not the first time that I've tried making a DC UPS for small devices. In my previous design, I followed a topology that is more comparable with offline or line interactive topology, where the power is switched from the main input to battery as an input source when there's a power cut. However, that thing has an inherent downside of being reset when the switching is happening. So that's not going to work for us, and we are going to switch to online topology for this new DC UPS.
But before we go into making the design choices for our DC UPS, let's first have a look inside the Wi-Fi mesh pod to understand what's the voltage and power demand is like. There's always a chance that it can simplify our design quite a bit. Getting inside the pod is just a few screws and a spudger away, so I'm just gonna zoom past that to get to the action.
Alright, so the quick thought on the teardown process, and this is where the power input is coming from. There is a power stage, so we can quickly measure actually that what that power is getting translated into and whether we can intercept it. So we can see that there's 1, 2, 3, 4, 5 power stages, and I can tell that by all those SMD inductors that we can see here. So that basically denotes that those are all power stages along with the PMIC and the capacitors for input and output. So that's a telltale sign. The actual Wi-Fi DSP is on the back side of this plate, and the antenna seems to be a trace. So in order for us to understand the power stage here, I'm going to inject a 12-volt power input, which should light up that LED, which means that the circuit is basically active right now. Meanwhile, I'm just gonna bring out my multimeter and check the voltages. Editor Dev here. Before I go full multimeter, my producer just reminded me that this part will not make any sense to people unless they are already electronic engineers. So I went back to giving an overview of a buck converter with this very simple but quite accurate design.
Feel free to pause and go through the details, or you can skip to the next section if you have just run out of fucks to give. In short, from left to right, higher voltage comes in with boarding pass, gets filtered and stabilized through the input capacitors C1 and C2 for a vibe check. Then the power management IC U1 takes them on a ride of switching the circuit on and off a few 100,000 times per second like a hyperactive kid on caffeine. And then that jagged on-off pulse of square wave goes through the airport immigration queue, which is the inductor L1, and sobers up a little. And then they gather at the output capacitors C3, C4 like it's the arrival lounge. And then they take the shuttle or power rails to their own individual destinations. Oh yeah, the N or enable pin works like the air traffic control, and that FB or feedback pin is basically the security checkup to ensure everything is in order. Okay, now that you know absolutely everything, let's get back to poking some power rails.
We have 12-volt input, but if I'm not mistaken, these are the output capacitors. So I would try to see what the power is like. This is 3.3 volt. This one is doing 5 volt output.
Normally, a module like this will have a main DC input of a standard voltage, like 12 volt in our case, and then step it down to all sorts of lower voltages that it needs for different purposes. So that's what we're looking at here trying to find the highest voltage rail, which we can use as our lowest safe operating input voltage.
This is also 1.1 volt. Anyways, meanwhile, the LED is white, means it's working just as expected, and the voltage that is actually being used is 5 volts or less. So it actually doesn't matter for us if we don't use 12 volt input, but use something on the line of like 9 volt or 8 volts as an input here, because the highest voltage that we are stepping down to is 5 volt. So even if the input is 6 volt, the entire circuit should still work as long as the power supply is delivering enough power.
And with all that, we have the boundary conditions for our design choices all figured out. So I'm just gonna shut the hell up for a bit, turn up the music, and get down to making the battery pack. Let's go.
Okay, that's one diode drop, and this one should be 2 diode drop, basically MOSFET's body diodes. So it's a 600 something, this should be 1200. Okay, fair enough. If I can show, like, switch that terminals, it will show that it's open circuit, because now I'm from positive to negative. So positive to negative, there is no connection, but that's the reverse polarity protection. So if you connect battery or something like that in reverse, it will actually that should that should start the charging process, and that should give us power as output on this. Yes, now the BMS is active, right? So in order to try whether our assumption works that this device works with 8.4 volt, let me connect this and see that yes, this lights up. And if we hold steady for a bit.
So that was easy. Now it's time to put things back together again.
So that was our mini DC UPS build. I understand this is a little bit more function over form, but this is just first of its kind, and I'm gonna keep on reiterating on this until it becomes more plug and play and easier to use by anybody. Let me know in the comments below what do you think of this build. Like if you liked the video, dislike if you disliked it, subscribe to the channel. See you in the next one. Alright, so while this UPS is good enough for most personal usage, I want to go a little bit further and do something a little crazy, just to demonstrate the point that this is a design flaw in this kind of devices itself, where the UPS can be built into this device without too much of a trouble on the manufacturer's part. I want to add an internal UPS to this device so that regardless of whether as a user I'm providing it with another UPS or power backup sources, it can continue to function, at least to hold up against momentary power losses. So that would be our next step. I am gonna go ahead and do that with a single battery, which should be enough for our 4 to 5 watts of power demand. Let's get started with that.
This is correct.
4.1 volt input. This should show 12 volt. Yes, so 12 volt is the output.